Hi, welcome back. This is Professor Ridge, and today's lesson is on section 3.4, solving rational equations and radical equations. So this should be mostly review, but let's go over all of it just in case. Alright, so what's a rational equation? Basically any equation that contains rational expressions, and that's fancy for fraction. Technically, right, it's a ratio of two polynomials, but fractions. Okay, so any equation containing rational expressions are called rational equations. Alright, so let's see if we can solve. Let's do some examples here. Okay, so our first step is we're going to clear the fractions by multiplying both sides by LCD of all the fractions. So in this case, the LCD is x minus 1 times x plus 2 So we're going to multiply both sides by x minus 1, x plus 2. And notice on the left side, the x minus 1's cancel, and you get the 2x plus 2 equals, and then on the right side, the x plus 2's cancel, and you get 3x minus 1. And this is kind of where, you can cross multiply, and that's true if the LCD is if there's nothing common to both of the denominators, and you have what's called, this is written as a proportion, but the actual technique is you multiply both sides by the LCD of all the fractions. Okay, and then you're going to solve the resulting equation. Now you have to decide, depending on what type of equation you get from here would tell you what technique to use. You might get a quadratic equation, you might get a linear equation. So, it's just, I'm just going to keep it general. Solve resulting equation. So in this case, we just get a linear equation. So we use the technique for solving linear equations, which is get all the x's on one side and isolate the x. So let's subtract 2x. Let's add 3. So we get 7 equals x. Now we have to take note, make sure that the solution, we're not sure it's the solution yet, is in the domain. So you got to plug it back into the original problem to make well, you just have to make sure it's in the domain, because when we multiplied both sides by the LCD, you're losing the information that the domain has to be restricted. X cannot equal 1 and x cannot equal negative 2. So 7's okay, and if you want to just double check to make sure, you plug it in and see if we get a true statement, which means it would be a solution. So we get 2 over 8, which is, 2 over 6, which is 1/3. And then on this side we get 3 over 9, which is 1/3. Check. Okay, so the solution is x equals 7. So this, this equation is equivalent to the original equation provided x is not equal to 1 or negative 2. Okay? Okay, let's try another one. The LCD is going to be x plus 5, x minus 5. So if I were to factor this, x plus 5, x minus 5. So the LCD is x plus 5, x minus 5. x plus 5, x minus 5, and I'm going to distribute it. So x plus 5, x minus 5. Okay, so the x plus 5 cancels and you get 2x minus 5 plus the x minus 5's cancel. You get 1 times x plus 5 equals both x plus 5, x minus 5 cancel, and we get 16. And we get 2x minus 10 plus x plus 5 equals 16. And again, this is a linear equation. So I'm just going to solve it like normal. Oh, look at that. We're going to get 7 again. So 7. And again, this may or may not be the original a solution to the original problem, because when we multiply both sides by the LCD, we're losing the information that x cannot be 5 or negative 5. Now, since it's not 5 or negative 5, you know, pretty confident that will be the solution, but we better check just in case. Sometimes you get what are called extraneous solutions, which are answer. We didn't do anything wrong mathematically, but it's not a solution. 7 squared minus 25. So we get 2 over 12 plus 1 over 2. Does that equal 16? 49 minus 25 is 24. So let's write 2 12s. So this will be 2 12s plus 6 12s, which is 8 12s. And if I reduce that, that's going to be divide by 2, 4, 6, divide by 4, that'd be 2 thirds. And then 16 24ths reduces to 2 thirds. So that checks out. So 7 is the solution. Now let's try another one. Okay, so let's try another one. 3 over m plus 2 over m equals 4m minus 4 over m squared minus 4. So the LCD is going to be m plus 2, m minus 2. I'm going to multiply that with each fraction. m plus 2, m minus 2. Now normally I don't write all that, I just write it once, but just to show you for your notes. And then m plus 2, m minus 2, and golden rule, what you do one side, do the other. So you're multiplying everything with the LCD for all the fractions. Okay, so for the first, the m plus 2's cancel, and we're going to get m minus 2 times 3, so I'll just put it in front. Second fraction, the m's cancel, you get 2, m plus 2, m minus 2. And this one, I'm going to distribute the m, so it's 4m squared minus 4m. 3m squared minus 6m plus, okay, so on scratch work I'll do, well, in my head I can go, that's m squared minus 4 times 2, 2m squared minus 8. Combine, so I got 5m squared minus 4m squared. Well, let's not do too much yet. Okay, let's get all, this is a quadratic equation, so you want to solve it with the techniques for quadratic equations. So this one I could probably factor. Let's see, I'm going to get subtract 4m squared from both sides, add 4m, So we got to get it equal to 0 first to see what we have. 2m minus 8 factors 8 that subtract to 2. So that's 4 and 2 minus plus. So m minus 4 equals 0, so m is 4. Or m plus 2 equals 0, so m is negative 2. Now, remember, these are possible solutions. They're solutions to the equation, this equation, but they may or may not be the solutions to the original equation because we lost information about the domain. And if you check, m equals to 4, 3 over 4 plus 2 plus 2 over 4. Does that equal 4 times 4 minus 4 over 4 squared minus 4? So we get 3 over 6 plus 2 over 4, which is 1 half plus 1 half, which is 1. Now this side we're going to get 16 minus 4 is 12 over 16 minus 4 is 12, which is 1. So it checks out. Now we're going to check m equals negative 2. We plug in 3 over negative 2 plus 2, and right there's the problem. This is 3 over 0 is undefined, so you can't use it. So m equals negative 2 is what's called an extraneous solution, meaning we got to throw it out. It's a solution to our equation after we multiplied both sides by the LCD, but it's not a solution to the original equation. So just m is 4. That's your only solution to the original problem. Alright, now let's try radical equations. And so with radical equations, if you recall, what you're going to do is the principle of squaring. You're going to square both sides. I should say the principle of powers, because we can do it to any power, not just square. So if for any positive n, if a equals b, then you can raise both sides. So again, it's like the golden rule. If we raise both sides to the nth power, then that's going to be a true statement too. Now, the problem here is that this is an if-then statement, not an if and only if statement. So it doesn't work both directions, meaning, for instance, if you had, let's say you had negative 2 squared equals negative 2 squared, or positive 2 squared. So if you looked, negative 2 squared equals positive 2 squared, because negative 2 squared is 4 and positive 2 squared is 4. But if we go backwards and take the squares away, negative 2 is not equal to positive 2. So it just works that if two numbers are equal and you square both numbers, that's true. But going backwards, not necessarily true. It could be true, it may not be true. So you have to check if you square both sides. So if we use this principle, it's a possible solution, and we have to check it in the original problem. So again, if I want to solve square root of 4x plus 1 equals 3, I'm going to use the principle of powers. I'm going to square both sides. So if that's true, then this is true. So the square and square root cancel each other. 3 squared is 9. Subtract 1. So 4x is 8. And then divide by 2, 4x is 2. Now we have to check it. Again, we're not checking to see that we did math errors. We're seeing if we have a problem with the logic over here. See if we got an extraneous solution. And this works. Square root of 9 is in fact 3, so it checks out. So our solution is x equals 2. Okay, so let's try another one. So our technique for solving radical equations is your first step is you isolate the radical. Okay, so we want to get the radical term all by itself. And then you're going to raise both sides. We're going to use the principle of powers to the power of the index of the radicand. Okay, so in this case, square root, the index is square, so we're going to square both sides. So if I square both sides, you get x minus 1 equals 25. And then you're going to solve the resulting equation, just like we did with the rational equations. Depending on what you get, is from there you use whatever technique's appropriate. So x is 26. Now we're going to check. Again, we're not checking just to make sure we did it right. We're checking because we could have done everything right and we get this extraneous solution that's not a solution to the original problem. So we're going to check this. So square root of 25 is 5. 5 plus 5 is 10. 10 does not equal 0. So this is an extraneous solution, and we say no solution to the original problem. Now, we could have, if we were paying attention, we could have noticed that right here, this is a contradiction, because how can a positive number equal a negative number? Right? So that's false. Always false. So we could have stopped right there if we were paying attention. Okay? Sometimes it's not obvious, and you work the problem out and you get an extraneous solution. So you always have to check in the original problem to make sure that your solution is in fact a solution to the original problem, because we're losing some information when we square both sides. And basically the only time we got to worry about it if we raise it to an even power. Okay, so solve cube root of 6x plus 9 plus 8 equals 5. So again, we got to get the radical by itself. So we're going to subtract 8 from both sides. So that's negative 3. We're going to raise both sides to the power of whatever the index is of the radical. So it's cube root, so we're going to cube both sides. So we get 6x plus 9 equals negative 27. Subtract, now we're going to solve the resulting equation. This happens to be a linear equation, so just get x by itself. And then divide by 6. So x equals negative 6. Now again, we got to check to make sure it's a solution. Now, since it's cube, this is not that necessary. It's going to work. So we're actually just checking to see that we didn't do any math errors. So 36 plus 9, negative 36 plus 9, that's negative 27. Cube root of that is negative 3 plus 8, and that equals 5. Check. Okay. All right, let's try this one. Again, we want to isolate the radical expression. So we get x plus 2. So we add 2 to both sides. All right, now we're going to raise both sides to the second power. So the square root cancel each other, 6x plus 7. And again, we should know our square formula. A plus b squared is a squared plus 2ab plus b squared. So that's going to be x squared plus 4x, 2 times x times 2, plus 4. Now this is a quadratic equation, so we want to get it equal to 0. So we got 0 equals x squared minus 2x minus 3. Factors of 3 that subtract to 2. It's 3 and 1. Negative, positive. So x minus 3 equals 0. Or x plus 1 equals 0. So x equals negative 1. And again, we squared both sides, so we have this problem with the logic that solutions to this equation may not be solutions to the original equation. So we have to check in the original problem. So if we check x equals 3, we got negative 2 plus square root of 6 times 3 plus 7. Does that equal 3? So we got negative 2 plus square root of 18 plus 7, which is 25, which is 5. And that equals 3. True. Okay, so that one's fine. Now check x equals negative 1. So I got negative 2 plus 6 times negative 1 plus 7. Does that equal negative 1? So negative 2 plus negative 6 plus 7 square root of 1. And that's true. Okay, so both of them are solutions. Negative 1 and 3. Alright, let's try another one. Now this one's a little more difficult. You got two radicals, and so we just get one of the radicals by itself. Which one doesn't matter. Okay, now we're going to square both sides. So we get x minus 3 equals, now use the square formula. A is going to be 5, and b is going to be the square root. So 5 squared is 25, minus 2 times 5 is 10 times the square root, x plus 2, plus the square root squared cancel each other, so you just get the x plus 2. You get the number inside. Okay. Now notice, this is a radical equation again, so you got to start over and you do the same technique. Get the radical all by itself. So let's just simplify stuff first. So let's see, we got x minus 3, that's 27. That's x, so I'm going to subtract x from both sides. Subtract 27 from both sides. So you got negative 30 equals negative 10 square root of x plus 2. Now, only if I can divide both sides by the number in front of the radical, I'll do it. If not, I'll just go ahead and start my process from there and square both sides. But since negative 10 divides on both sides, I'm going to go ahead and do it. Okay, so now we've isolated the radical. So do the power rule, square both sides. So we get 9 equals x plus 2. Subtract 2, x equals 7. And again, this is a possible solution, so we got to check it. 7 minus 3 plus 7 plus 2, does that equal 5? So square root of 4, which is 2. Square root of 9, which is 3. 2 plus 3 equals 5. Check. So that's my solution. Now just to let you know, sometimes, all the solutions don't work. Sometimes they all work. So, you always have to check back in the original problem. Make sure that any of your possible solutions are in fact solutions. Okay, so that concludes the lesson for 3.4. Go to My Math Lab and complete your exercises there. I'll see you next time.